Assalamu alaikum, welcome back to my channel Learn with Your Buddy, and today I'm here with another video of our compiler design series. And today we will learn about deterministic finite automata, and in short we will call it DFA. Now this is a module of lexical analyzer and it is used to recognize tokens using regular languages. Now, what is DFA? Well, a DFA is a finite automaton where for each state and input symbol there is exactly one transition and no epsilon transition used in lexical analysis. Now, the formal definition of DFA, now it's important as these are the symbol like DFA is defined as 5 tuple. Okay, for Q it's the finite set of states. For the input symbol we will use epsilon, and for transition function we will use delta, and for start state we will use Q naught, and for set of final state we will use F. But the start state and the final state can be varied with different alphabets. Alright, then we will know DFA in compiler design. Now it converts input characters into tokens and based on regular expressions and implemented using transition table and efficient and fast token recognition. And it is an example from now. We need to design a DFA that accepts all the binary strings and ends with 1. Now suppose a computer has binary number that is 0 and 1, and we need to accept the number where that ends with 1. Alright, so here if we see the last number is 1, then that will accept, and if the last number is 0, that will not accept. So here suppose we have two states Q0 and Q1, alright, and the final state is Q1 there. We have some problems to solve, but we basically solve them on TOC, but sometimes we need to solve them in compiler design in our university exams. Here you guys can see that I have drew a DFA. I mean here A, B, C, they are the 3 states, and the starting state is A and the ending state is B. Now how do you know the ending state? Now there you will see double circles, alright, and another one is C. Now here in DFA there is only one way thing, that A can go to B, A can go to C, but not A can go to B and B can come to A. Okay, that will never happen in deterministic. That's why it's called deterministic finite automata. And after that here we have a table that is A, and as B is the final state, that's why there is a star with B, and then we have C. Now state A when if A needed A to go to B, I mean a smaller A to go to B, and A needed a smaller B to go to C, and B needed a smaller A to go to B again, and then B again needed the smaller B to go to B, to herself, I mean to that self actually, and then C needed A and B to go to that self already again like B. So here we will do a code with this. Okay, if input ends with 1, DFA reaches Q1, Q is a final state and string is accepted, 101 is accepted and 1100 is rejected. Alright, so after that we will go to our code. Okay, so yeah, here we know about this. Here we have written our two states, and then if Q naught is 0, then it will return to Q naught, I mean Q0. If Q0 is 1, then it will return to Q1. If Q1 is 0, then it will return to Q0, and if Q1 is 1, that means it will return to Q1. Alright, so yeah, we will just write a binary string, then we will see if the string accepts. Now let's run it. Okay, so we will enter a binary string, suppose 1102. Now 1101. Now yeah, this ends with A, so it will accept the string. Now let's write something different. Alright, okay, so let's write something which is not a binary. So yeah, 1 2 3, that's rejected. Now actually it's not right. Okay, we need to write between 0 and 1. So after that let's again write about what 1 yeah 110, and now that also rejected because this is not ending with 1. All right, so yeah, this was our deterministic finite automata code. I hope you guys have understood the assignment of this code and the input and output. So, and if you guys find my videos useful, please like, comment and subscribe my YouTube channel, and I'll see you guys in the next video. Till then, stay safe, take care, as it's very much cold in Bangladesh right now, so please guys take care of yourself. So yeah, that's it, keep practicing. That's all. Allah Hafiz.